Hello there, and welcome to the Sleepless Scientist, a quiet corner of the night where your thoughts can soften and ideas drift by like slow-moving clouds. Tonight, we'll wander together into the nature of light, that familiar yet endlessly mysterious presence that threads its way through everything you've ever seen, felt, or understood. But before we begin, you might take a slow breath, letting the day's noise loosen its grip. If the lights around you feel a bit too bright, you can dim them, or let the soft hum of your room become a backdrop for your mind to rest on. And if you'd like to share a moment of connection, you can leave a comment telling me where in the world you're listening from and what time it is for you right now. It's always comforting to imagine listeners scattered across different places, all tuning in to this gentle journey at their own quiet hour. In a moment, we'll start exploring a question that has followed humanity for centuries. What exactly is light? We think of it as something that simply lets us see. Yet the more deeply we look, the more light begins to resemble a universal language, a silent messenger stretching across the universe, carrying stories older than planets and gentler than breath. So feel free to settle in. Let your shoulders drop a little. Let your thoughts wander if they want to. We'll still be here, slowly unfolding the story of light together. And now, when you're ready, let's begin this quiet exploration. When you hear the word light, the first image that might come to mind is the warm glow of a lamp, the morning sun slipping through a curtain, or the soft glimmer of stars scattered across a night sky. We grow up believing that light is simply what allows us to see, a companion guiding our days and fading with our nights. But in truth, the light that reaches your eyes is only the smallest fraction of what light really is. It is the tip of an enormous shimmering iceberg, most of which remains forever unseen. Imagine, for a moment, standing beside a calm lake at dawn. The surface looks still, but beneath it currents move in quiet patterns, carrying stories the surface cannot show. Light behaves the same way. The narrow slice of colours you and I can see, reds, greens, blues, and everything between, is only the surface. Beyond it stretches a vast ocean of invisible forms of light. Radio waves drift outward from distant galaxies. Microwaves whisper softly from the earliest moments of the universe. Infrared light glows from warm bodies and cooling stars. Ultraviolet light hums at the edge of what our eyes can sense. X-rays flare from ancient cosmic collisions. Gamma rays, the most energetic of all, streak silently through the darkness. Each of these is part of one single family, one spectrum, one continuous thread. At their core, they are all the same phenomenon wearing different masks. They have different rhythms, different wavelengths, different personalities, but they're all variations of light, moving through the same cosmic sea. If your eyes could see across the entire spectrum, the night sky would look astonishingly different. You'd see the Milky Way glowing with heat. Nebulae would swell like bright clouds. Invisible storms of radio waves would sweep past in gentle waves. The universe would feel more alive, more crowded, more connected. There is something quietly humbling in knowing that our eyes perceive only a doorway, not the whole room. It reminds us that light isn't just what we see. It's what shapes the space around us, whether we notice or not. And then there is an even stranger truth. Light doesn't simply illuminate the universe, it reveals it. Every distant star you've ever gazed at sent out its message long before you were born. When the glow of a star reaches you, it carries a moment from the past, a tiny fragment of history travelling endlessly forward. The starlight you see tonight may have begun its journey when early humans first learned to make fire, or when dinosaurs still walked across warm plains. In this way, Light becomes a bridge across time, not just across space. It allows you to look into the past without ever leaving where you are. Light also moves in a way that defies our everyday intuition. It travels unbelievably fast. So fast that in the time it takes you to blink, it could circle the Earth 7 times. And yet, even at this astonishing speed, light is patient. It waits. It carries its stories across empty stretches of space for thousands, millions, even billions of years, never tiring, never growing old. Each beam is a quiet courier, faithful to its path. But perhaps the most mysterious part of all is that light doesn't need a medium to travel through. Sound needs air. Waves on a beach need water. But light moves through empty space as if emptiness were its home. Physicists describe this through fields and vibrations, but in softer words, you can think of it as a ripple of energy travelling through the fabric of space itself, a gentle trembling that carries information from one corner of the cosmos to another. When you put all these pieces together, the vast spectrum, the messages from ancient stars, the ability to travel through the void, light begins to feel like something more than a tool for vision. It becomes a language written into the universe itself, one that every star, every planet, every atom participates in. You and I simply witness a small portion of it, translated into the colours and shapes we recognise. As we continue this journey, we'll slowly peel back more of the layers hiding behind the familiar glow. For now, you can simply rest with the thought that the universe is humming with light you cannot see, a quiet chorus surrounding you at every moment, even in the stillness of night. Light has a way of slipping through the cracks of our understanding, changing shape just when we think we finally know what it is. If you ask it to behave like a wave, it will. If you ask it to behave like a particle, it will do that too. And if you watch closely, you may find that it behaves like a third thing entirely, something that doesn't fit neatly into any label we have. This gentle strangeness lies at the heart of what makes light so mesmerizing. To begin, imagine holding a sheet of fabric between your hands. If you shake one end gently, a smooth ripple travels across it, rising, falling, flowing. In many ways, this is how light behaves when we let it move freely. It spreads out in waves, carrying energy and soft undulations. These waves can be long and slow, like radio waves drifting through space, or short and quick, like ultraviolet rays humming from the sun. Each form of light has its own rhythm, its own pace, its own texture. If light were only a wave, the story would end here. But life rarely gives us single-story answers. When you shine certain kinds of light onto a metal surface, tiny particles leap out from it, as if the light itself arrived not as a smooth ripple, but as little bursts, each carrying a precise and tiny packet of energy. Scientists eventually realize that these packets behave as if they are particles, tiny units of light, arriving one by one, each with its own discrete punch. They called these particles photons, but you can think of them as pinpoints of brightness, each carrying a small note in the symphony of the universe. Still, even the word particle can mislead us. These photons aren't like sand grains or pebbles you can place in a jar. They're more like flickers, tiny sparks of energy that appear when light interacts with matter. Their particleness is really a personality that light chooses to show only when necessary. The deeper truth is softer and more elusive than either waves or particles alone. Perhaps the clearest illustration comes from a simple yet astonishing experiment involving two narrow openings. Imagine aiming a gentle stream of light toward a wall but placing a small barrier in its path, with two tiny slits carved side by side. If light were made only of particles, you'd expect it to form two bright lines on the wall, one behind each slit. If it were purely a wave, you would see a series of alternating bright and dark bands, the unmistakable pattern of ripples interfering with each other. The surprising thing is that you get the wave pattern, even when you send the light through one photon at a time. Each tiny flicker seems to sense the presence of both slits, even when it chooses only one path. It behaves as though it is aware of all possibilities before settling into a single outcome. It's as if each photon carries multiple whispered futures inside itself, then gently collapses into one when it meets the screen. To make the story even stranger, if you place a detector at the slits to see which path the photon actually takes, the wave pattern disappears completely. The light suddenly behaves like particles again, choosing a definite route, no longer showing the delicate interference bands. Just by watching, we change the outcome. When unobserved, the photon explores possibilities like a wandering thought. When observed, it selects a single path, like a coin landing on one side after spinning in the air. Physicists have mathematical ways of describing this behaviour. Long equations, complex symbols, intricate explanations. But for our quiet journey tonight, it may be more soothing to think of a light as something that listens to the situation. When given freedom, it spreads out gracefully like a ripple across a still pond. When asked to make a choice, it condenses into a tiny flash. Light adapts, shifts, and responds. It is flexible in a way that challenges our instincts about how the world should behave. If you picture a beam of sunlight drifting through a room, you're seeing countless photons arriving like tiny footsteps of energy. But you're also seeing a wave, a gentle, continuous rhythm that stretches across space. Both pictures are true, and yet neither is complete on its own. This dual nature is more than a scientific puzzle. It hints at something deeper, the idea that the universe may not be built from simple solid objects, but from patterns, possibilities, and relationships. Light teaches us that the world can hold multiple truths at once. It reveals that reality is not rigid, but fluid, able to shift depending on how we approach it. You can imagine light as a dancer capable of moving in two styles. One moment it glides across a floor in smooth, sweeping motions, filling the room with flowing grace. The next moment it taps lightly in precise beats, stepping in sharp, discrete rhythms. The dance is the same. The dancer is the same. Only the expression changes. When scientists tried to measure the energy of each photon, they found that it isn't random. Instead, the energy is tied to how quickly the light's wave vibrates. The faster the rhythm, the more energy each tiny packet carries. Rather than presenting this as the familiar formula, we can simply say that light's brightness and colour depend on its tempo. The way a melody's feeling depends on whether it's played quickly or slowly. Light has a beat, and each photon is a single note lifted from that beat. This idea of rhythm connects the particle and the wave. A photon is like a single step taken from a larger dance. The wave is the music underlying all those steps. Both exist together, one within the other. You can also think of photons as messengers carrying tiny fragments of information. When they interact with matter, they deliver these fragments. Energy that warms your skin, colours that paint your world, signals that allow cameras and sensors to work. Yet when travelling alone across space, each photon is a ripple of the electromagnetic field, the vast, invisible ocean that fills all of existence. Seen this way, the wave is not something outside the photon. It is the environment that shapes its journey. Perhaps the most poetic truth of all is that light is whatever the universe needs it to be. It flows when flowing helps it move. It concentrates when concentration lets it interact. It carries whispers from distant galaxies, yet also lights the page of a book resting in your hands. In every form, light remains the thread stitching together the fabric of reality. Sometimes visible, often hidden, always quietly present. If you'd like to continue, we can drift onward into session 3, where light becomes even stranger, linking distant particles in ways that feel almost like magic. Just let me know when you're ready. There are moments in science when a discovery feels less like an answer and more like a doorway, a quiet opening leading into a realm where the familiar rules of distance, time, and separation begin to soften. Entanglement is one such doorway. It involves light behaving in a way that seems to whisper, "Connection runs deeper than space." And while the mathematics behind this phenomenon can feel overwhelming on the surface, the heart of the idea can be understood gently, without symbols or sharp edges. Tonight, we will walk through that doorway slowly. Imagine for a moment a pair of twins who grow up side by side. They share experiences, memories, laughter, and the kind of unspoken understanding that often forms between people who have lived closely intertwined lives. Then one day, these twins travel in separate directions, one across the sea, the other across a continent. Despite the distance, they still feel threads of connection, the kind that surface in moments where one laughs at something the other would have found amusing, or senses something faintly familiar in a distant place. These connections are emotional and human, not physical, yet they give us a soft metaphor for the strangeness of entanglement. Now, instead of human twins, imagine two tiny flickers of light, two photons, created together in an event so brief and delicate that even calling it a moment feels too long. When a certain type of crystal is struck with the right kind of light, two new photons can emerge as if born from the same heartbeat. In the instant of their creation, they share properties so closely that it becomes impossible to describe one without the other. They are like twins in the purest sense, not only related but arising from the same pulse of energy. What happens next is what makes entanglement so extraordinary. These twin photons, once created, move apart. One might travel through a laboratory fibre, the other might shoot off in the opposite direction, passing through mirrors, lenses, or even across long stretches of open air. They drift farther and farther from one another, and yet no matter how much distance grows between them, a few centimetres or even kilometres, they behave as though they remain part of a single shared system. Imagine gently turning a tiny dial that corresponds to the orientation of one photon. When you check the orientation of the other, it aligns in a way that perfectly complements the first, as if they conspired long ago on how they would behave. The key point and the soft mystery at the heart of it all is that their responses match even when there is no time for a signal to pass between them. Not a whisper, not a flicker, not even the briefest flash of influence travelling at the speed of light. The match appears instantly. This is where entanglement begins to feel like a quiet kind of magic, though science does not treat it as magic at all. It treats it as a profound hint that the universe is woven together at a level deeper than physical distance. These photons are not sending information to one another. They are not communicating in any direct way. Instead, they behave like two parts of a single story. A story written, in some sense, before they ever parted. A gentle way to picture this is to imagine a book printed on pages bound together. If you tear the book in half and send one part across the world, the pages do not suddenly stop belonging to the same story. They remain linked because their connection was written into them from the beginning. Entangled photons are similar. Their link is not created by distance, it is created by origin. When scientists first observed this behaviour, it caused considerable discomfort. Even Einstein, who viewed the universe with a blend of deep intuition and rigorous logic, found this phenomenon unsettling. He famously called it spooky action at a distance, not because he believed the photons were acting in a supernatural way, but because he felt that the universe should not allow influences to leap across space instantly. Everything, in his view, should be bound by the gentle speed limit of light, the cosmic rule-keeper that ensures cause precedes effect. Yet over time, countless experiments have confirmed entanglement as a real and reliable feature of the world. And each time those twin photons were sent farther apart, sometimes hundreds of kilometers, the strange connection persisted. The universe remained consistent in its quiet insistence that these shared patterns are not bound by distance. Still, it is important to understand what this connection is not. It is not a means of communication. The matching results cannot be used to send messages faster than light. Instead, the connection is simply a reflection of the deep structure of the quantum world, a place where possibilities exist in a kind of soft superposition until they meet the touch of observation. To think of it more gently, each photon carries within it a cloud of possible behaviors. When one is observed, the cloud of possibilities collapses into a single outcome, and the twin photons cloud collapses in harmony. This harmony is not caused by one photon influencing the other across space. It is caused by the fact that their possibilities were woven together from the start, like two halves of a musical chord that resonate in unison, even when played on different instruments. Another helpful metaphor is to imagine two dancers who learned their routine together. Once separated, each dancer may perform alone. Yet when a cue arrives, a soft note, a gesture, a moment of stillness, both respond in patterns shaped by their shared training. They are not communicating, they are remembering in parallel. This is what entanglement reveals about light. Beneath its familiar glow lies a subtle unity. Photons are not isolated sparks scattered across a vast universe. They are threads in a web that stretches across everything, touching particles, atoms, molecules, and even the biological systems that form our bodies. When you look at the world around you, the glimmer of a street lamp, the reflection in a puddle, the faint shine on a window, you are seeing only the surface of a deeper interconnectedness. Entanglement also offers a poetic invitation to imagine that the universe is not made of separate, lonely pieces, but of relationships, of patterns, harmonies, and quiet bonds that transcend space. It suggests that connection is not an afterthought of the cosmos, but woven into its most fundamental layers. Even in the smallest places and the tiniest particles of light, the universe displays a preference for unity. As we rest with that thought, the story of light becomes even broader, stretching into gravity, space-time, and the shape of the cosmos itself. When you're ready, we can drift gently into the next chapter of this journey, where light reveals not just connection, but the very architecture of the universe. If you step outside on a clear night and tilt your head upward, the sky appears calm and orderly, almost like a vast dome stretched over the world. Stars seem fixed in place, planets drift slowly along gentle arcs, and the darkness between them feels still and uncomplicated. Yet beneath that serene surface lies a deeper structure, a landscape not made of soil or mountains, but of space-time itself. And one of the most surprising truths about this landscape is that light, that weightless traveller we think we understand, can feel its shape. To begin softly, imagine walking across a quiet field after a light snowfall. The snow looks smooth from a distance, but as you draw closer, you notice small dips and rises, the faint imprint of wind, the gentle settling of ice crystals, the delicate footprints of passing animals. Your steps follow these contours without you needing to think about them. You simply move along the terrain that exists beneath you. Light behaves in a similar way. It doesn't consciously choose a path. It simply travels along the curves and folds of space-time, following the natural shape of the universe around it. When the space ahead is flat, light moves in straight lines. When the space is bent or warped, light gracefully follows that curvature, as effortlessly as water flowing along a riverbed. Gravity, in this gentle view, is not a force that pulls on light. Instead, it is the bending of the stage on which the entire cosmic play unfolds. Massive objects, stars, planets, black holes, press into space-time the way a heavy object might press into a soft cushion, creating dimples and valleys. Light then travels through these valleys, its path bending not because something tugs on it, but because the shape of space has changed. One of the most iconic demonstrations of this truth happened during a total solar eclipse in 1919. As the moon slipped perfectly across the face of the sun, the sky darkened enough for astronomers to observe stars positioned near the sun's edge. Their light, passing close to the sun's mass, bent ever so slightly, causing the stars to appear in places where they did not truly reside. This was not an illusion caused by atmospheric trickery. It was space-time revealing its curvature, with light tracing the contours. Einstein had predicted this effect years before, suggesting that starlight would behave as if space around the sun were gently curved. When the eclipse observations matched his prediction, the world responded with a mixture of awe and disbelief. It was as though the universe had whispered, "The stage beneath you is not as flat as it seems." If we soften the technical language, we can say that light always chooses the gentlest, straightest path available. But straight means something different in curved space. It means following the fabric of the universe wherever it bends. This concept may sound abstract, but we see its echoes in everyday life. Consider a marble rolling across a curved bowl. To an observer looking down from above, the marble's path appears to curve, though no invisible hand pushes it. The marble simply follows the shape of the bowl. Similarly, light follows the shape of space-time. The bending of light becomes even more fascinating when we scale upward from stars to galaxies. Entire clusters of galaxies, vast collections of billions of suns, create immense valleys in space-time. When light from a more distant galaxy passes through these valleys, it stretches, twists, and sometimes splits into multiple images. This effect, called gravitational lensing, is one of the universe's most elegant phenomena. It turns space-time into a natural telescope, magnifying distant objects we would otherwise never be able to see. If you've ever looked at a spoon and seen your reflection appear stretched or upside down, you have a small intuition for lensing. The spoon's curved surface bends the light leaving your face, creating a distorted image. In the same way, gravity bends the light passing near massive objects, but instead of polished metal, the lens is invisible, created by the shape of space itself. Some lensing events look like arcs or rings of light in the sky, delicate and faint, circling around a dark center. These formations are called Einstein rings, and while the phrase can sound technical, the idea behind them is simple. Light from a background galaxy reaches us from multiple directions, its path curved around a massive object in the foreground. The result is a halo of light, as if the universe were wearing jewellery fashioned from distant starlight. What makes this phenomenon particularly astonishing is that we can use it to detect things we cannot see directly. Dark matter, the elusive substance that doesn't emit light, reveals its presence through lensing. Even though dark matter is invisible, it still shapes space-time. It creates valleys in the cosmic landscape, and light slips into those valleys, bending slightly. By studying the bending, we can map the unseen. Light becomes an explorer of the hidden world, revealing structures that would otherwise remain silent. This quiet truth leads to a profound realization. Light is not merely passing through the universe, but tracing its architecture. It outlines gravity's fingerprints. It highlights the invisible. It transforms curvature into knowledge. To bring this closer to home, imagine walking down a hallway lit only by a candle. You notice the way shadows stretch and bend along the walls, revealing the subtle contours of the space you move through. The candlelight shows you where the walls dip inward or curve outward. In the cosmos, light from distant galaxies plays the role of that candle, illuminating the shapes carved into space-time by gravity. Perhaps the most poetic way to hold this in mind is to imagine space-time as a soft fabric stretched across vast distances. Massive objects press into it gently, like stones resting on a stretched sheet. Light travels along this sheet, weaving between the stones, curving gracefully as it moves. The path it follows is always the path of least resistance, the most natural course available. There is a quiet beauty in this interplay between light and gravity. One shapes the stage, the other traces its lines, and through their dance the universe becomes visible to us, not as a flat map, but as a living, breathing landscape with depth and form. As we continue our journey, this relationship grows even more dramatic. The gentle curves of starlight give way to the extreme contours near black holes, where light reaches the limits of what it can do. When you're ready, we can drift into that deeper, darker frontier, where light meets the edge of its own endurance. If the universe were a grand landscape of valleys and hills shaped by gravity, then black holes would be the deepest, most mysterious hollows carved into that terrain. They are places where space-time curves so steeply that even light, the swiftest traveller in the cosmos, cannot escape. And yet, despite their ominous reputation, black holes are not monstrous devourers. They are quiet sculptors, shaping the universe with gravity so intense that they rewrite the rules of space and time. In the soft rhythm of tonight's journey, we can think of them less as violent objects and more as profound boundaries, the edges of where light is allowed to go. To understand a black hole in a gentle way, imagine holding a sheet of fabric between your hands and dropping a small pebble in the centre. The fabric dips slightly. Drop a heavier stone and it sinks deeper. Now imagine placing an object so dense, so compact, that it stretches the fabric downward into a well with sides so steep that nothing placed in it could climb out. This is the essence of a black hole, a place where the curvature becomes so sharp that every path, every direction, every possible future leads inward, not outward. At the boundary of this well lies a line called the event horizon. Some people describe it as a point of no return, but tonight we can imagine it as the silent edge of a quiet lake. On one side, light skims across the surface and escapes into the open air. On the other, any ripple gets pulled downward, caught in a current stronger than its own ability to move. When a photon reaches the event horizon, it does not scream or break. It simply finds that every direction it can travel bends inward. It has no path to freedom, not because it is slow, but because all roads lead down. Just outside this boundary is one of the strangest regions in the universe, the photon sphere. The name sounds technical, but the concept is beautifully simple. It is a glowing ring-shaped region where light attempts to curve around the black hole. A photon entering this zone orbits the black hole like a tiny planet circling a sun, though the path is delicate and unstable. A slight nudge sends it spiralling inward. A gentle push outward lets it escape. If you could stand safely outside this sphere, which admittedly nature does not allow, you would see your own reflection wrapped all the way around you, your image stitched into a perfect circle where light orbits the void. Perhaps the most enchanting truth about black holes is that we can never see them directly. Anything that crosses the event horizon disappears, taking all colour, shape and light with it. What we can see, however, is the way light behaves just outside that invisible boundary. Streams of gas and dust falling toward a black hole heat up and glow brightly, forming swirling disks of hot matter. These disks shine across the spectrum from radio waves to X-rays, creating cosmic storms of light around the darkness. The black hole itself does not emit light, but the space around it becomes a luminous frame, emphasizing its presence like a halo around a shadow. One of the most hauntingly beautiful consequences of such intense gravity is gravitational time dilation, a concept that can feel abstract but can be softened with imagery. Imagine walking near a waterfall where the water rushes downward with overwhelming force. The closer you stand to the edge, the stronger the pull feels. Time behaves in a similar way near a black hole. The closer you are to the horizon, the more slowly time passes for you compared to someone far away. If you drifted near a black hole while a friend watched from a safe distance, your clock would tick in slow motion from their perspective. You wouldn't feel the difference, but they would see you moving as though wrapped in thick honey. Light too stretches as it climbs away from a black hole, its colour drifting toward deeper shades, like a musical note slowing into a lower pitch. Black holes serve as mirrors of the universe's hidden architecture. When astronomers look at the sky, they sometimes find arcs, rings and distortions created by black holes bending the light from objects behind them. The black hole acts as a lens, magnifying distant galaxies. This natural magnification reveals details that would otherwise remain invisible, turning black holes into cosmic magnifying glasses. The first real image of a black hole, captured in 2019 by a network of telescopes scattered across Earth, showed precisely this: a glowing ring of light orbiting an invisible centre, like a warm ember encircling an eternal night. And yet, the most poetic truth about black holes is that they are not merely endpoints. They are not cosmic trash bins swallowing matter forever. They can also be beginnings. In the deepest mathematical descriptions of space-time, black holes hint at connections to new regions of space, perhaps even other universes or distant parts of our own. While these ideas remain speculative, they offer a sense of wonder. The possibility that the universe uses extremes to create doorways. Black holes also play a role in the evolution of galaxies. At the centre of nearly every large galaxy, including our own Milky Way, lies a supermassive black hole with millions or even billions of times the mass of the Sun. These giants do not merely sit quietly. They regulate the growth of galaxies, shaping the behaviour of stars and gas. Light from the material swirling around them can outshine entire galaxies for brief dramatic moments. In this way, black holes become both destroyers and creators, sculpting cosmic neighbourhoods on scales unimaginable. Despite their intensity, it is important to remember something simple and deeply calming. Black holes are not common dangers. They are far away, silent, steady, and respectful of their boundaries. They do not chase or hunt. They simply exist, playing their role in the universe's grand design, curving space-time in ways that allow us to understand the nature of existence itself. In the soft glow of this understanding, black holes become less ominous and more awe-inspiring. They show us that light has limits, places where even its incredible speed meets its match. They reveal that the universe contains edges, boundaries, and silent thresholds where the familiar rules break gently. As we drift forward, we'll explore how light continues to weave the universe together, bending around massive objects and revealing hidden structures scattered across cosmic distances. When you're ready, we'll wander into the subtle world of gravitational lensing, where light becomes both the artist and the artwork. When we think of light, we often picture something straightforward, a beam travelling in a line, steady and predictable, like a ray from a flashlight passing across a dark room. Yet on cosmic scales, light behaves with a delicacy and sensitivity that feels almost artistic. It bends, stretches, curves, and sometimes multiplies itself, not because it chooses to, but because the universe gently invites it to follow the shape of space. This phenomenon, known as gravitational lensing, is one of the most quietly beautiful interactions between light and gravity. It is here, in these subtle bends and distortions, that the universe reveals its deepest secrets. To begin softly, imagine standing above a calm pond on a summer afternoon. If you drop a single pebble into the water, the ripples spread outward in smooth circles. But now imagine that beneath the surface lies a buried stone or a gentle dip in the sand. The ripples, upon reaching that uneven terrain, stretch slightly, curve around the obstacle, or even split into new patterns. The water's movement adjusts gracefully to the shape below, revealing the hidden structure without ever needing to touch it. Light moves through the universe in a similar way. When it travels through regions of flat space-time, it spreads in straight, smooth lines. But when it passes near massive objects, galaxies, star clusters, or dark matter halos, the underlying terrain of space dips or folds slightly, causing light to bend as it moves. This bending doesn't break the rules of physics. It simply reflects the fact that light always follows the straightest possible path through whatever shape spacetime takes. And when that shape curves, the straightest path is curved too. This natural bending turns the universe itself into a giant lens, an invisible magnifying glass capable of enlarging and distorting distant objects. When a distant galaxy lies behind a massive cluster of stars or dark matter, its light can be stretched and brightened as it journeys toward us. Sometimes, the galaxy appears elongated, like a smear of paint across a night sky. Sometimes it becomes a shimmering arc. In rare and remarkable cases, the arrangement is so perfect that the background object forms a complete ring of light around the foreground mass. These luminous circles are called Einstein rings, though in our calmer tone we might think of them simply as halos of cosmic chance, places where light has found the most graceful route around a mass and reaches us from all directions at once. One of the most poetic aspects of gravitational lensing is that it allows us to see things that are otherwise too faint, too distant, or too small to observe directly. The universe, in this way, lends us its own tools of vision. It uses its gravity to gather light, focus it, and bring it into reach. It's as though space-time itself leans forward and whispers, "Here, let me show you something you wouldn't have seen on your own." A gentle example comes from distant galaxies formed when the universe was still young. Many of them are so far away that their light is unbelievably faint by the time it reaches Earth. But when a massive foreground object lies between us and that distant galaxy, the light becomes brighter and more concentrated, the way a magnifying glass focuses sunlight into a warm spot. This cosmic magnification allows astronomers to study galaxies 10, 20, or even 30 times more faint than would normally be possible. The lensing effect turns space-time into a quiet collaborator, working alongside our telescopes. Occasionally, gravitational lensing produces something even more surprising. Multiple images of the same object. Picture a candle placed behind a glass paperweight. Instead of seeing one flame, the curved glass might show 2 or 3 reflections, each arriving along a slightly different path. In space, These reflections are not illusions, but real photons that took separate routes around a massive object. They arrive at Earth with tiny differences in timing, sometimes minutes apart, sometimes days. Each path is shaped by the curvature of space-time, forming a kind of cosmic choreography where light dances around mass in elegant loops. This effect becomes especially important when the background object is something dynamic, like a quasar, a brilliant beacon powered by a supermassive black hole. When a quasar flickers, the different light paths caused by lensing carry the flicker to Earth at different times. By studying these delayed echoes, astronomers can measure distances across the universe and even estimate how fast the cosmos is expanding. Once again, light becomes both the messenger and the message, revealing not only the structure of space but also the tempo of cosmic evolution. But perhaps the most profound use of gravitational lensing is in studying dark matter, the mysterious invisible substance that makes up most of the mass in the universe. Dark matter does not emit or reflect light. It does not glow, shimmer, or shine. It hides, utterly silent, and yet it bends space-time. It carves valleys into the cosmic landscape just as stars and galaxies do. Light passing through those valleys bends accordingly, even though nothing visible lies in its way. By analysing the distorted shapes of thousands of distant galaxies, scientists can create maps of these invisible structures. It's a little like watching leaves float down a river. The leaves follow currents you cannot see directly, but their motion tells you where the hidden streams lie. In the same way, light reveals the presence of dark matter, tracing the contours of something that cannot be observed in any other way. The universe, through gravitational lensing, lets us read invisible handwriting written upon its own fabric. All of this, the arcs, the rings, the multiplied images, comes from the most fundamental truth about light. It responds faithfully to the shape of space-time. It does not resist, argue, or question. It flows along whatever curvature exists, as if honouring the quiet architecture of the universe. And in doing so, it becomes a guide, helping us sense the shape of things far beyond our reach. There is a strange comfort in this. Light bends but never breaks. It adapts but never loses its essence. It moves through every part of the universe with grace, tracing outlines we would never notice on our own. Even in the vastness of space, even in the presence of unimaginable gravity, light remains both delicate and dependable. It becomes our companion, our illustrator, our cosmic storyteller. And as we follow this thread, the story of light continues unfolding into realms where it becomes not only a cosmic cartographer but also the fundamental energy source for life. When you're ready, we can drift next into the world of living things, where light becomes food, fuel, and breath, the quiet foundation upon which entire ecosystems rise. If you've ever stepped into a forest at midday, you may have felt a quiet sense of calm settle around you. The gentle sway of leaves, the scent of earth, the dappled patterns of sunlight drifting across the ground. Within that stillness, there is a process unfolding that is both ancient and astonishing. It's a silent conversation between light and life, one so fundamental that without it, nearly every creature on Earth, including you and me, would vanish. This conversation is photosynthesis, the soft alchemy through which plants, algae, and certain bacteria turn sunlight into energy. At first glance, it seems like nothing more than a biological trick. Leaves turn green, the sun shines, and plants grow. But if we lean closer and slow our thoughts, we begin to see that photosynthesis is one of the purest demonstrations of light's ability to connect, transform, and sustain. Imagine sunlight as a gentle stream of tiny visitors, photons, each carrying a small packet of energy. These photons travel from the sun's surface, through empty space, and across the quiet air until they touch a leaf. Some photons miss and bounce away. Some pass straight through. But others land on just the right spot inside the leaf, where a delicate pigment called chlorophyll waits to greet them. Chlorophyll is what gives plants their green colour, but its deeper purpose is far more profound. Think of chlorophyll as a welcoming hand, ready to catch a passing photon the way someone might catch a falling snowflake. The moment a photon is absorbed, its energy leaps into the leaf, setting off a chain of events that feel almost musical. A cascade of tiny vibrations, shifts and transfers that ripple across structures inside the cells. You could imagine this moment as a soft spark awakening within the leaf. The energy from the photon doesn't stay in one place. It moves, travelling through pigment molecules in a process so efficient that some scientists compare it to a perfectly choreographed dance. Instead of blundering randomly through the leaf, the energy flows along pathways designed to guide it swiftly toward the heart of the process, a place known as the reaction centre. But in our gentle storytelling, we don't need to think of the reaction centre as a machine. We can think of it as a peaceful room deep inside the plant, where the arrival of each photon's energy gives life a tiny push forward. It's here that water molecules are quietly split apart. The water's oxygen, held within those molecules like a secret, is released into the air. Every breath you have ever taken, every breeze that has ever moved across your skin, every fire that has ever burned bright, owes its oxygen to these quiet, persistent reactions happening inside leaves. The remaining components of the split water become part of a process that forms simple sugars, small energy-rich molecules that serve as the building blocks for nearly everything plants do. From these sugars come stems, roots, petals, fruit, seeds, and the slow rise of entire forests over centuries. These sugars also feed animals that eat the plants, and animals that eat those animals, weaving sunlight into the fabric of food webs across the planet. If you trace your meals backward, the fruit in a bowl, the grain in a loaf of bread, the vegetables on a plate, the milk that came from a grazing animal, all of them led back to sunlight captured by chlorophyll. Light becomes food. Food becomes energy. Energy becomes movement, thought, memory, emotion. In a very real sense, you're walking around each day powered by recycled light. It's humbling to realize how ancient this process is. Long before humans appeared, long before animals swam or walked or flew, early bacteria were already performing a form of photosynthesis. Over billions of years, they slowly filled the atmosphere with oxygen, transforming a once hostile world into a place where complex life could flourish. The air you breathe, the oceans that shimmer under the sun, the soil beneath your feet, all were shaped by countless tiny creatures capturing photons and turning them into fuel. Even the colours of the world carry the imprint of photosynthesis. Plants appear green because chlorophyll prefers to use red and blue light for its energy work. Green light, less useful to the process, is mostly reflected. What you see as the colour of leaves is, in a sense, the leftover light, the part not needed by the plant. The Earth's colour palette is built upon these quiet decisions made by ancient molecules. But photosynthesis is not only a matter of chemistry, it contains a kind of quiet intelligence that scientists are still exploring. Some evidence suggests that the energy from photons doesn't simply hop randomly from molecule to molecule. Instead, it may spread out briefly, like a soft cloud of possibilities, and then settle on the most efficient path forward. This is not a rigid mechanical process. It is graceful and adaptive, almost as if the plant were listening for the most harmonious way to move energy toward growth. This delicate efficiency has inspired humans to explore new technologies. Solar panels, for instance, are our attempt to mimic the leaf. a way to capture sunlight and turn it into electrical energy. But even our best designs remain less effective than the humble plant that quietly converts sunshine into life. Nature has had billions of years to practice, and the elegance of photosynthesis is the result of that long, patient refinement. There is also a poetic side to all of this. Think of the sunlight touching your skin on a warm morning. That same light has nourished fields of grain, orchards of fruit, and forests stretching across continents. Think of a leaf trembling slightly in the breeze. Inside it, tiny streams of energy are flowing, carrying the warmth of the sun into the heart of the plant. Think of a child breathing in fresh air, the oxygen filling their lungs having been released by countless leaves across the world. Light threads itself into the pulse of life. It becomes breath, warmth, food, growth. Without it, Earth would be a silent, frozen world, a planet without colour, without movement, without the dream of consciousness. So the next time you walk past a tree or see a patch of grass swaying by the roadside, you might pause for a moment and remember that you're witnessing a quiet miracle. Each blade of grass is catching tiny parcels of sunlight and turning them into the architecture of life. And as we continue this gentle journey, we'll follow light even deeper into the living world, into creatures that make their own glow, and into the human eye, where photons become meaning. When you're ready, we can drift softly into the realm of bioluminescence, where light itself becomes a language of communication. If you've ever walked along a beach at night and seen the waves glow with a strange blue fire, or watched fireflies dance through a quiet field, you've witnessed one of nature's most enchanting gifts, living light. Unlike the glow of the sun or the reflection of moonlight, bioluminescence emerges from life itself, from cells, tissues, and chemical dances happening silently in the dark. It is light used as language, a way for organisms to communicate, attract, warn, confuse, or simply endure the night. And like all forms of light, it carries threads of connection linking the smallest creatures to the vast rhythms of the planet. To enter this world gently, imagine drifting in a small boat on a calm sea. The night is starless, the air is warm, and the water is black and still. You trail your hand through the surface, and suddenly the water ignites into soft blue sparks, swirling around your fingers like tiny galaxies. These sparks are created by plankton, microscopic life forms that release light when disturbed. For them, this glow may serve as a warning to predators or a way to startle creatures that swim too close. But for you, it feels like touching the night sky. Bioluminescence depends on a simple yet elegant partnership between a molecule that carries potential energy and a protein that helps release it. Scientists sometimes describe these components with technical names, but for our soothing journey, we can think of them as a tiny lantern and a gentle match. When the lantern's stored energy meets the match's guiding touch, a soft glow emerges. This glow can be blue, green, yellow, or even red, depending on the creature and its habitat. The chemistry behind the light is precise, but the effect is dreamlike, a quiet pulse of radiance blooming in darkness. In fireflies, this light becomes part of a courtship ritual. On warm summer evenings, male fireflies rise into the air and blink in specific patterns, each species with its own rhythm. They paint the night with tiny signals, each flash a soft invitation. Female fireflies watch from the grass below, waiting for the pattern that matches their own. When they flash back, the air fills with a wordless conversation of light. These gentle signals allow the fireflies to find one another in the dark, weaving companionship into the night through simple pulses of radiance. Some deep-sea creatures use bioluminescence for the opposite purpose, to disappear. Consider a fish swimming through the black depths of the ocean where no sunlight ever reaches. Predators lurking far below look upward for silhouettes, dark shapes blocking the faint glow from above. To avoid becoming shadows, some fish produce their own soft light on their undersides, matching the glow from above and erasing their outline. This strategy, called counter-illumination, is a form of natural invisibility cloaking. The fish does not shine brightly. It shines just enough to blend into the faint ambient glow, dissolving into the water like a whisper. Other creatures use bioluminescence to lure prey. The anglerfish, perhaps one of the ocean's most haunting figures, carries a glowing lure at the end of a small filament that hangs in front of its mouth. In the unending darkness, this tiny light resembles drifting plankton. Smaller fish approach out of curiosity, not knowing that the glimmer is attached to a predator lying perfectly still in the black water. Here, light becomes a lure, a tiny beacon in an otherwise empty night. On land, fungi sometimes emit a soft green glow that filters through forest soil. Known as foxfire or fairy fire, this bioluminescence can be seen on logs and fallen branches as a faint shimmer, like embers left behind after an unseen fire. The glow may help attract insects that spread the fungus's spores, though scientists are still learning the full purpose behind the light. For countless generations, people wandering through woods at night would catch glimpses of this phenomenon and weave stories about spirits, lanterns, or hidden magic. In a way, these stories reflect a deeper truth. Light has always guided our imagination, even when it arises from sources far smaller than the stars. One of the most breathtaking examples of bioluminescence occurs during mass gatherings of certain plankton near tropical shores. When the water is stirred, by waves, by swimmers, or by passing boats, it bursts into bright swirling trails. Beaches in places like the Maldives, Puerto Rico, and parts of Vietnam sometimes glow like starlit carpets during these events. Each glowing dot is an individual organism reacting to movement, yet together they create a spectacle that feels almost cosmic, as though the ocean itself were holding a mirror to the Milky Way. What connects all these examples is not just their beauty, but the way light becomes a form of language. Unlike sound, which can be muffled by water or distance, and unlike scent, which drifts slowly and unpredictably, light is immediate. It cuts through darkness with clarity. A single flash can say, "Here I am, stay away," or "Come closer." It can mimic prey, conceal a body, summon a mate, or signal danger. Even though we often think of communication as a human trait, voices, words, symbols, the living world shows us that light is one of the earliest and simplest forms of expression. There is something soothing in knowing that nature has been communicating this way for millions of years. Long before humans invented lanterns, navigation lights, or the glow of city streets, the Earth was already alive with its own gentle signals. Tiny sparks in forests, deep-sea lanterns drifting in the black, shimmering waves glowing under the moon. The biosphere has always been written in part by light, and in a deeper sense, bioluminescence reminds us that light is not confined to the heavens or bound only to stars. It is a universal phenomenon expressed by life itself. Plants harness sunlight to create oxygen and food. Plankton turn motion into radiance. Fireflies map their world in flashing strokes. Even in the deepest, darkest trenches of the ocean, where no sunlight can ever reach, life brings its own illumination. This reveals a profound truth. Light is not merely an external force. It is woven into the fabric of biology. Cells can produce it, sense it, respond to it, and use it to shape behavior. When a photon touches a leaf, life begins. When a photon is crafted inside a tiny organism drifting in the ocean, meaning is conveyed. As we continue wandering through the story of light, we'll next step into the human experience, how our eyes, brain, and consciousness turn photons into vision, perception, and the rich tapestry of the world we think we see. When you're ready, we'll drift gently into that space where light becomes awareness itself. If you close your eyes for a moment and slowly open them again, the world returns in a quiet flood of colours, shapes, shadows, and motion. It may feel instantaneous, almost effortless, as if sight was simply the mind turning on. Yet behind that smooth, immediate experience lies a delicate, almost miraculous sequence of events. It begins with a single photon, one tiny visitor arriving from the world outside, and ends with something much larger: awareness. To understand this softly, imagine that every photon reaching your eyes is a small messenger carrying just one piece of information: a hint about colour, a suggestion of brightness, a fragment of shape. These messengers arrive in vast numbers, pouring toward you from every direction. From the glow of the sky, the reflection of objects, the shimmer of water, the faint gleam of distant street lamps. They fall onto your eyes like gentle rain. The first place they touch is the cornea, the smooth outer window of the eye. It bends the incoming light ever so slightly, guiding it inward. The lens behind it adjusts its shape like a tiny living sculpture, curving subtly to bring the world into focus. Each adjustment is automatic, quiet, and precise, like a craftsman making invisible corrections 100 times per second. But the true magic happens deeper inside, in the retina. The retina is a thin layer of tissue lining the back of your eye, no thicker than a sheet of paper, yet packed with millions of tiny cells capable of sensing light. These cells come in two families: rods and cones. Their names may sound simple, but their roles are profound. Rods are sensitive to faint light. They help you see in the dimness of dusk or starlight. Cones respond to colour. They translate different wavelengths of light into the hues we recognise: reds, greens, blues, and all the subtle shades in between. The moment a photon meets one of these cells, something astonishing happens. In cones and rods lives a molecule, a quiet, patient one, that waits for light to arrive. When a photon touches it, the molecule changes shape. That single shift triggers a cascade of tiny electrical signals. These signals travel through a network of supporting cells, growing and combining until they reach the optic nerve, a thick cable of millions of fibers carrying these signals toward the brain. In this soft description, each photon is like a gentle tap on a door, and the changing molecule is the door opening. The electrical signals are whispers travelling down a hallway, and the optic nerve is a long path leading to a waiting listener. Once the signals reach the brain, the true symphony begins. Contrary to what we might expect, the brain does not merely replay the light in a one-to-one fashion. It interprets, organises, edits, and enhances. It looks for patterns and boundaries. It fills in gaps. It imagines missing pieces. The world you see is not simply the raw light entering your eyes. It is a carefully constructed story created by your brain in real time, based on the clues provided by photons. Consider colour. There is no inherent redness in a red apple. What we call red is simply light, arriving in waves of a certain rhythm, a certain tempo of vibration. The cones in your eyes detect this tempo, and your brain translates it into a sensation: the warmth of red, the calm of green, the cool hush of blue. Even without using any formulas, we can say that colour is the mind's way of giving personality to the rhythm of light. Consider depth. The world looks three-dimensional, not because your eyes capture depth directly, but because your brain compares two slightly different images. one from each eye, and blends them into a single understanding of distance. The brain also uses light and shadow, texture, and motion to infer how near or far an object is. In a sense, depth is a story shaped from many small clues. Even motion can be an illusion created by light. If you've ever stared at a fan spinning so fast it appeared still, or watched a wheel seem to reverse direction on camera, you've glimpsed how the brain sometimes interprets light in ways that diverge from physical reality. It does so not to mislead, but to maintain coherence, to keep the world understandable even when the information arrives in fragments. The human relationship with light extends beyond vision. Deep within your eyes lie cells that do not contribute to sight at all, yet still respond to light in subtle ways. They help regulate your circadian rhythm, the inner clock that keeps track of day and night, wakefulness and sleep. These cells respond particularly to blue-tinted light, the kind found in morning skies. When they're active, they send signals to your brain telling it to stay alert. When the light dims and shifts toward warmer tones in the evening, those cells grow quieter, allowing melatonin, the hormone of rest, to rise. This is why sunlight feels invigorating, why dawn can lift your mood, and why bright screens at night can make it harder to fall asleep. Light isn't only something we look at, it's something that whispers to our biology, telling our bodies when to rise, when to rest, and how to align ourselves with the rhythms of Earth. Even memory and emotion are touched by light. A sunrise can remind you of a childhood morning. The warm glow of a lamp might stir a sense of comfort. The flicker of candlelight can create feelings of calm or reflection. These responses come not from the photons themselves, but from the associations stored in your mind, connections woven between light and experience. There is also something quietly profound in knowing that every image you've ever seen, every face, every landscape, every page of a book, came to you through photons. Your entire visual life has been built from countless tiny visitors that travelled across space to meet your eyes. Without those encounters, the world would be nothing but silent shapes in the dark. Photons carry no intent, no agenda. They merely arrive. Yet in their arrival, the mind finds meaning. This is one of the most beautiful paradoxes of perception. Light itself does not contain the world. The brain constructs it, moment by moment, using light as its raw material. If you pause for a moment and look at any object near you, a cup, a plant, a folded blanket, you're seeing not the object itself, but the light leaving its surface. The object does not travel to you, its photons do. You never actually touch the world with your eyes. You touch only the messages carried by light. This subtle truth places perception at the center of our connection to the universe. Light is not just a physical phenomenon. It is the bridge between what exists and what we experience. Without it, the world would still be there, but unreachable, unreadable, silent. As we continue this gentle journey, we'll follow light out of the human mind and back into the cosmos, into its role as the universe's oldest archive, carrying memories of events billions of years old. If you'd like to drift onward, Session 10 will explore how every photon becomes a tiny historian of time. If you close your eyes for a moment and slowly open them again, the world returns in a quiet flood of colours, shapes, shadows, and motion. It may feel instantaneous, almost effortless, as if sight were simply the mind turning on. Yet behind that smooth, immediate experience lies a delicate, almost miraculous sequence of events. It begins with a single photon, one tiny visitor arriving from the world outside, and ends with something much larger: awareness. To understand this softly, imagine that every photon reaching your eyes is a small messenger, carrying just one piece of information. A hint about colour, a suggestion of brightness, a fragment of shape. These messengers arrive in vast numbers, pouring toward you from every direction, from the glow of the sky, the reflection of objects, the shimmer of water, the faint gleam of distant street lamps. They fall onto your eyes like gentle rain. The first place they touch is the cornea, the smooth outer window of the eye. It bends the incoming light ever so slightly, guiding it inward. The lens behind it adjusts its shape like a tiny living sculpture, curving subtly to bring the world into focus. Each adjustment is automatic, quiet, and precise, like a craftsman making invisible corrections 100 times per second. But the true magic happens deeper inside in the retina. The retina is a thin layer of tissue lining the back of your eye, no thicker than a sheet of paper, yet packed with millions of tiny cells capable of sensing light. These cells come in two families, rods and cones. Their names may sound simple, but their roles are profound. Rods are sensitive to faint light. They help you see in the dimness of dusk or starlight. Cones respond to colour. They translate different wavelengths of light into the hues we recognise: reds, greens, blues, and all the subtle shades in between. The moment a photon meets one of these cells, something astonishing happens. In cones and rods lives a molecule, a quiet, patient one, that waits for light to arrive. When a photon touches it, the molecule changes shape. That single shift triggers a cascade of tiny electrical signals. These signals travel through a network of supporting cells, growing and combining until they reach the optic nerve, a thick cable of millions of fibers carrying these signals toward the brain. In this soft description, each photon is like a gentle tap on a door, and the changing molecule is the door opening. The electrical signals are whispers travelling down a hallway, and the optic nerve is a long path leading to a waiting listener. Once the signals reach the brain, the true symphony begins. Contrary to what we might expect, the brain does not merely replay the light in a one-to-one fashion. It interprets, organises, edits, and enhances. It looks for patterns and boundaries. It fills in gaps. It imagines missing pieces. The world you see is not simply the raw light entering your eyes. It is a carefully constructed story, created by your brain in real time, based on the clues provided by photons. Consider colour. There is no inherent redness in a red apple. What we call red is simply light arriving in waves of a certain rhythm, a certain tempo of vibration. The cones in your eyes detect this tempo, and your brain translates it into a sensation. The warmth of red, the calm of green, the cool hush of blue. Even without using any formulas, we can say that colour is the mind's way of giving personality to the rhythm of light. Consider depth. The world looks three-dimensional, not because your eyes capture depth directly, but because your brain compares two slightly different images, one from each eye, and blends them into a single understanding of distance. The brain also uses light and shadow, texture and motion to infer how near or far an object is. In a sense, depth is a story shaped from many small clues. Even motion can be an illusion created by light. If you've ever stared at a fan spinning so fast it appeared still, or watched a wheel seem to reverse direction on camera, you've glimpsed how the brain sometimes interprets light in ways that diverge from physical reality. It does so not to mislead, but to maintain coherence, to keep the world understandable even when the information arrives in fragments. The human relationship with light extends beyond vision. Deep within your eyes lie cells that do not contribute to sight at all, yet still respond to light in subtle ways. They help regulate your circadian rhythm, the inner clock that keeps track of day and night, wakefulness and sleep. These cells respond particularly to blue-tinted light. the kind found in morning skies. When they are active, they send signals to your brain telling it to stay alert. When the light dims and shifts toward warmer tones in the evening, those cells grow quieter, allowing melatonin, the hormone of rest, to rise. This is why sunlight feels invigorating, why dawn can lift your mood, and why bright screens at night can make it harder to fall asleep. Light isn't only something we look at, it's something that whispers to our biology, telling our bodies when to rise, when to rest, and how to align ourselves with the rhythms of Earth. Even memory and emotion are touched by light. A sunrise can remind you of a childhood morning. The warm glow of a lamp might stir a sense of comfort. The flicker of candlelight can create feelings of calm or reflection. These responses come not from the photons themselves, but from the associations stored in your mind, connections woven between light and experience. There is also something quietly profound in knowing that every image you've ever seen, every face, every landscape, every page of a book, came to you through photons. Your entire visual life has been built from countless tiny visitors that travelled across space to meet your eyes. Without those encounters, the world would be nothing but silent shapes in the dark. Photons carry no intent, no agenda. They merely arrive. Yet in their arrival, the mind finds meaning. This is one of the most beautiful paradoxes of perception. Light itself does not contain the world. The brain constructs it, moment by moment, using light as its raw material. If you pause for a moment and look at any object near you, a cup, a plant, a folded blanket, you're seeing not the object itself, but the light leaving its surface. The object does not travel to you, its photons do. You never actually touch the world with your eyes. You touch only the messages carried by light. This subtle truth places perception at the center of our connection to the universe. Light is not just a physical phenomenon, it is the bridge between what exists and what we experience. Without it, the world would still be there, but unreachable, unreadable, silent. As we continue this gentle journey, we'll follow light out of the human mind and back into the cosmos, into its role as the universe's oldest archive, carrying memories of events billions of years old. If you'd like to drift onward, Session 10 will explore how every photon becomes a tiny historian of time. If you close your eyes for a moment and slowly open them again, the world returns in a quiet flood of colours, shapes, shadows, and motion. It may feel instantaneous, almost effortless, as if sight were simply the mind turning on. Yet behind that smooth, immediate experience lies a delicate, almost miraculous sequence of events. It begins with a single photon, one tiny visitor arriving from the world outside, and ends with something much larger: awareness. To understand this softly, imagine that every photon reaching your eyes is a small messenger carrying just one piece of information: a hint about colour, a suggestion of brightness, a fragment of shape. These messengers arrive in vast numbers, pouring toward you from every direction. From the glow of the sky, the reflection of objects, the shimmer of water, the faint gleam of distant street lamps. They fall onto your eyes like gentle rain. The first place they touch is the cornea, the smooth outer window of the eye. It bends the incoming light ever so slightly, guiding it inward. The lens behind it adjusts its shape like a tiny living sculpture, curving subtly to bring the world into focus. Each adjustment is automatic, quiet and precise, like a craftsman making invisible corrections 100 times per second. But the true magic happens deeper inside in the retina. The retina is a thin layer of tissue lining the back of your eye, no thicker than a sheet of paper, yet packed with millions of tiny cells capable of sensing light. These cells come in two families: rods and cones. Their names may sound simple, but their roles are profound. Rods are sensitive to faint light. They help you see in the dimness of dusk or starlight. Cones respond to colour. They translate different wavelengths of light into the hues we recognise: reds, greens, blues, and all the subtle shades in between. The moment a photon meets one of these cells, something astonishing happens. In cones and rods lives a molecule, a quiet, patient one, that waits for light to arrive. When a photon touches it, the molecule changes shape. That single shift triggers a cascade of tiny electrical signals. These signals travel through a network of supporting cells, growing and combining until they reach the optic nerve, a thick cable of millions of fibres carrying these signals toward the brain. In this soft description, each photon is like a gentle tap on a door, and the changing molecule is the door opening. The electrical signals are whispers travelling down a hallway, and the optic nerve is a long path leading to a waiting listener. Once the signals reach the brain, the true symphony begins. Contrary to what we might expect, the brain does not merely replay the light in a one-to-one fashion. It interprets, organises, edits, and enhances. It looks for patterns and boundaries. It fills in gaps. It imagines missing pieces. The world you see is not simply the raw light entering your eyes. It is a carefully constructed story, created by your brain in real time based on the clues provided by photons. Consider colour. There is no inherent redness in a red apple. What we call red is simply light, arriving in waves of a certain rhythm, a certain tempo of vibration. The cones in your eyes detect this tempo, and your brain translates it into a sensation: the warmth of red, the calm of green, the cool hush of blue. Even without using any formulas, we can say that colour is the mind's way of giving personality to the rhythm of light. Consider depth. The world looks three-dimensional, not because your eyes capture depth directly, but because your brain compares two slightly different images, one from each eye, and blends them into a single understanding of distance. The brain also uses light and shadow, texture, and motion to infer how near or far an object is. In a sense, depth is a story shaped from many small clues. Even motion can be an illusion created by light. If you've ever stared at a fan spinning so fast it appeared still, or watched a wheel seem to reverse direction on camera, you've glimpsed how the brain sometimes interprets light in ways that diverge from physical reality. It does so not to mislead, but to maintain coherence, to keep the world understandable even when the information arrives in fragments. The human relationship with light extends beyond vision. Deep within your eyes lie cells that do not contribute to sight at all, yet still respond to light in subtle ways. They help regulate your circadian rhythm, the inner clock that keeps track of day and night, wakefulness and sleep. These cells respond particularly to blue-tinted light, the kind found in morning skies. When they're active, they send signals to your brain telling it to stay alert. When the light dims and shifts toward warmer tones in the evening, those cells grow quieter, allowing melatonin, the hormone of rest, to rise. This is why sunlight feels invigorating, why dawn can lift your mood, and why bright screens at night can make it harder to fall asleep. Light isn't only something we look at, it's something that whispers to our biology, telling our bodies when to rise, when to rest, and how to align ourselves with the rhythms of Earth. Even memory and emotion are touched by light. A sunrise can remind you of a childhood morning. The warm glow of a lamp might stir a sense of comfort. The flicker of candlelight can create feelings of calm or reflection. These responses come not from the photons themselves, but from the associations stored in your mind, connections woven between light and experience. There's also something quietly profound in knowing that every image you've ever seen, every face, every landscape, every page of a book came to you through photons. Your entire visual life has been built from countless tiny visitors that travelled across space to meet your eyes. Without those encounters, the world would be nothing but silent shapes in the dark. Photons carry no intent, no agenda. They merely arrive. Yet in their arrival, the mind finds meaning. This is one of the most beautiful paradoxes of perception. Light itself does not contain the world. The brain constructs it, moment by moment, using light as its raw material. If you pause for a moment and look at any object near you, a cup, a plant, a folded blanket, you're seeing not the object itself, but the light leaving its surface. The object does not travel to you. Its photons do. You never actually touch the world with your eyes. You touch only the messages carried by light. This subtle truth places perception at the centre of our connection to the universe. Light is not just a physical phenomenon. It is the bridge between what exists and what we experience. Without it, the world would still be there, but unreachable, unreadable, silent. As we continue this gentle journey, we'll follow light out of the human mind and back into the cosmos, into its role as the universe's oldest archive, carrying memories of events billions of years old. If you'd like to drift onward, Session 10 will explore how every photon becomes a tiny historian of time. If you imagine the universe as a grand ancient city, filled with pathways and alleys and great stretches of open space, then light is its most tireless traveller, a wanderer who has moved along every road since the beginning of time. It travels with a steadiness that borders on the sacred, always at the same astonishing pace, never a bit faster or slower. This pace, which scientists measure with numbers and symbols, can be softened into something simpler. Light moves as quickly as anything in the universe is allowed to move. It is the universe's speed limit, its ultimate boundary for how fast information, cause and effect can ripple across existence. To begin gently, picture yourself standing on a long, quiet shoreline. A wave rolls toward you with a calm, rhythmic precision. You cannot make it arrive sooner, nor can you slow it down. It comes at its own pace, unhurried and unforced. Light behaves in much the same way. No matter how you try to catch up with it, whether you move toward it, away from it, or rest perfectly still, the speed at which it reaches you remains constant. It is like a cosmic heartbeat, steady and unwavering. This constancy is one of the most beautiful and puzzling aspects of the universe. Most things slow down or speed up depending on how we approach them. A car seems to pass faster if you're driving toward it and slower if you're moving away. Sound changes tone depending on the motion of its source. But light is different. It arrives at the same pace for everyone, everywhere. Its steadiness is not just a property of light itself, but a foundational rule written into the architecture of space-time. And because light refuses to travel faster or slower, it shapes everything else. Time stretches or compresses to protect this constancy. Distances shift. Motion becomes relative. The fabric of reality bends to ensure that light speed remains untouched. We can avoid the equations entirely by imagining this truth as a quiet agreement the universe made with itself. Light shall always move at this pace, and the rest of reality will adjust accordingly. This rule leads to something profound. Nothing with mass can ever reach the speed of light, not because it lacks determination, but because as anything with mass accelerates, it feels more and more resistance from the structure of space-time. It is as though space-time gently says, "This is far enough," preventing matter from ever touching light's realm. Light, being weightless, is the only traveller able to move freely along this upper boundary. everything else must follow slower paths. This speed limit sets the boundaries of causality, the rule that effects cannot outrun their causes. It keeps the universe coherent, preventing chaos from unraveling the order of events. If something could travel faster than light, it could, in principle, arrive somewhere before it departed, creating loops of paradox. But the universe avoids such contradictions by establishing light's pace as a dividing line between what can influence what and when. And yet, even with this incredible speed, light is not instantaneous. This is one of the most emotionally resonant truths in all of astronomy. Every message that light carries, whether from a nearby star or a distant galaxy, arrives late, sometimes slightly late, sometimes heartbreakingly late. The sun's light takes about 8 minutes to reach us. The light from Alpha Centauri takes more than 4 years. The glow from some galaxies takes billions of years to complete its journey. Each photon is a traveller bringing us a memory of something that no longer exists exactly as it once was. In this sense, astronomy is not the study of the present universe, but a study of cosmic echoes. The universe as it once was, frozen in countless beams of light drifting toward us. Each observation is a moment of time travel, a glimpse into ancient eras. When we observe a distant quasar, we are seeing an object that burned brightly when the universe was young. When we photograph a galaxy cluster, we are capturing a moment from a cosmic age long past. This delay also reveals a poignant truth. The farther we look into space, the farther we look into time. Light becomes a messenger that bridges enormous gulfs between then and now, letting us witness the slow unfolding of cosmic evolution. It allows us to see stars being born, galaxies merging, planets forming, all in the past tense. It shows us not just what the universe contains, but how it has lived, breathed, and changed. Even within our daily lives, light speed affects how we experience the world. When you look at someone across a room, you're seeing them as they were a tiny fraction of a moment ago. The delay is so small that it goes unnoticed, but it is always there. If you gaze across a landscape, the scene you observe is a collection of slightly older moments from one point to another. And when you look up at the night sky, this layering of memories becomes profound, a tapestry woven from countless ages of light. The constancy of light speed also ensures that information is woven coherently through space. If light could accelerate, communicate instantly, or outrun time itself, the universe's order would dissolve. Instead, light anchors reality. It ensures that events unfold in a consistent sequence, that cause precedes effect, and that the universe remains readable. Without this boundary, the cosmos would feel chaotic and unstructured, a place without rhythm. Yet light's unchanging speed is not a limitation, it is a gift. It creates the structure that allows galaxies to form, stars to shine, and life to exist. It shapes the geometry of space-time, influencing everything from the orbit of planets to the paths of photons sliding around black holes. It gives the universe a kind of order, a quiet pulse. There is another layer to this story, one more intimate and gentle. Light's speed creates a sense of wonder in us. Because light takes time to reach us, we're always receiving delayed messages from the cosmos. This distance between cause and perception builds mystery. It invites curiosity. It reminds us that the universe is not a static picture, but a vast and evolving story, one we can read only a line at a time. And there is something calming in knowing that light is always in motion, always arriving, always carrying the soft truths of the universe toward us. It does not hurry, yet it does not rest. It moves at the edge of possibility, holding the fabric of reality together with its steady, unwavering pace. When you're ready, we can continue into session 12, where we bring light back down to Earth and explore how it has become the quiet, invisible infrastructure of modern life, the threads connecting continents, devices, and people across the globe. If you look around your room right now, you may see stillness, a quiet lamp, a sleeping phone, a laptop resting nearby. Yet despite this calm, the air around you is humming with activity. Signals pass through your walls or through the floor, through the night sky above your home. Conversations leap beneath oceans. Images travel across continents. Voices stretch from one side of the planet to the other in the time it takes to blink. And beneath all this movement, beneath the messages, the connections, the endless flow of information, lies one simple thing: light. To understand this softly, imagine millions of tiny pulses of brightness, far too faint and too fast for your eyes to detect, racing through thin strands of glass as fine as a human hair. These strands lie buried beneath city streets, woven across landscapes, and stretched across the ocean floor. They are fibre optic cables, the arteries of modern communication, carrying light from one place to another with astonishing precision. Inside each cable, light travels not in open space, but through a guided path, bouncing gently along the walls of the fibre like a whisper travelling through a narrow hallway. Each pulse of light represents a bit of information, a letter, a pixel, a tone of someone's voice. When billions of these pulses move together, they form entire conversations, movies, songs, maps, and memories. The world you interact with online, the messages you send, the videos you watch, the calls you make, is carried almost entirely by light shaped into patterns. What makes fibre optics remarkable is not only their speed, but their gentleness. Because the light inside these cables is carefully protected from the outside world, it can travel for long distances without losing clarity. Even across the ocean, where cable paths stretch for thousands of kilometres beneath the waves, the signal arrives with its meaning intact. In this way, light becomes a silent courier weaving continents together. And then there is the sky, the invisible highways above us, crowded with satellites sending signals to Earth. Many of these signals ride on forms of light that lie outside the visible spectrum, such as radio waves and infrared beams. These wavelengths behave gently, spreading over large distances and passing through clouds and weather without much difficulty. When your phone picks up a GPS location, or when a ship determines its position in fog, what they are really doing is listening to faint pulses of light arriving from orbiting satellites. Each pulse contains timing information so precise that your phone can compare the delays between different signals and determine exactly where you are on the planet's surface. In a softer view, it's as if the Earth is surrounded by a constellation of tiny lanterns, each blinking rhythmically. Your device looks up, listens to a handful of those lanterns, and uses their gentle rhythms to place you on the map. Without light, even light you cannot see, this would be impossible. Wi-Fi works in a similar way. When your device connects to a wireless network, it is exchanging tiny ripples of invisible light with a router. These ripples carry information in patterns, subtle changes in amplitude or phase, like gentle variations in the way a dancer moves through a routine. Even though you cannot see these ripples, they fill the room with structure. The space around you becomes a medium where light performs quiet choreography, creating a bridge between your device and the wider world. Every modern technology we rely on, from medical imaging to weather forecasting to navigation, uses some form of light. Even lasers, which may seem cold and mechanical, are among the most beautifully precise forms of light ever created. A laser produces a beam so orderly, so harmonious, that every photon moves in step with every other. This coordinated rhythm allows lasers to read barcodes, carry internet signals, cut through metal, scan the Earth's surface from orbit, and even measure the distance from Earth to the Moon with astonishing accuracy. Despite how advanced these systems are, they all rest on simple principles we have already explored. Light travels quickly, carries information, and interacts with matter in predictable yet elegant ways. The digital world is, at its core, a world sculpted by photons. Your devices are not magical. They are layers of glass, metal, semiconductors, and coded instructions that teach light how to behave. Light pulses forward, carrying meaning. Electronics interpret it, rearrange it, and send it out again. When you place a video call to someone across the planet, the light leaving your screen is converted into patterns that race through cables, bounce between satellites, and arrive in another person's device half a world away. That person then sees your face because your photons have been translated into their photons. In this quiet exchange, distance collapses. Two people, separated by oceans and time zones, share a moment through the gentle work of light. Even the simple act of sending a message carries a kind of poetry. A thought forms in your mind. You type words onto a screen. The words become patterns of light inside a cable. Those patterns flow outward, crossing vast distances, and at the end of their journey, they become thought again, reconstructed in someone else's mind. Light becomes meaning. Meaning becomes connection. It is easy to forget how extraordinary this is. We live in a world where it feels almost mundane to send information instantly across the globe. Yet beneath the convenience lies a profound truth. We have learned to harness the same force that carries starlight across galaxies and use it to speak to one another. In the softest sense, the digital age is built on tamed starlight, light guided, shaped and organised so that it serves as our messenger. It is the same light born in stars, the same light used by plants to grow, the same light that forms memories in your eyes. Now it also forms the backbone of human communication. When you picture a modern city, shimmering towers, neon lights, streets glowing at night, you can imagine invisible rivers of light flowing beneath and above it. These rivers do not shine or flicker in ways we can see, but they carry the heartbeat of global civilization. As we continue, our journey moves from technology back into the deeper nature of reality itself, the field that underlies everything, the ocean from which light emerges. When you're ready, we can drift gently into session 13, where we explore the universal sea that gives rise to every photon. If you imagine peeling back the layers of reality, first the objects around you, then the air, then the atoms within everything, you might expect eventually to reach emptiness, a kind of silent void where nothing at all exists. But the deeper we look, the more we discover something surprising. Beneath matter, beneath particles, beneath anything we can point to, there lies a kind of ocean, not a physical ocean with waves and salt and depth, but a vast invisible sea that fills all of space. This sea is known as the electromagnetic field, but for our quiet journey tonight, we can think of it simply as the field beneath everything. A gentle, ever-present presence that exists even when the world appears still. Light, in this softer view, is not an object flying through space like a tiny stone. It is a ripple travelling through this universal sea, a vibration, a tremor, a shimmering wave moving through a medium that cannot be seen but can always be felt. In the same way that a pebble dropped into a pond creates spreading rings, a disturbance in this field creates what we call a photon. A photon is not a separate thing, but a pattern of motion, a pulse moving outward. To picture this, imagine standing beside a perfectly calm lake at dawn. The surface is glassy, untouched, and quiet. Then you drop a small pebble into the center. The water itself does not move from one side of the lake to the other. Instead, a pattern moves. The ripples. They are not the water. They are the movement of the water. Light behaves in exactly this way. It is the movement of the field beneath everything, the whisper that travels through the silence, the ripples on an unseen ocean. This universal field is always present. It fills the space between galaxies, threads through the vacuum between particles, and quietly surrounds you at every moment. Even in a room where all the lights are turned off, the field is still there, waiting, poised, capable of carrying motion. Light emerges from it whenever energy is added, the way a ripple emerges when you touch the surface of water. This idea may sound abstract, but we can soften it further. Think of the universe not as dots of matter in empty space, but as patterns in a fabric. The fabric is the field, and everything that exists, photons, electrons, atoms, the glow of sunrise, is a particular pattern woven into it. Light is simply one of the gentlest patterns, the one that travels freely across the cosmic fabric. One reason this idea is so comforting is that it allows us to think of the universe as unified rather than fragmented. Instead of countless separate particles darting through the void, we have a continuous presence, a field that connects every place to every other. Light is the way that this presence expresses itself. It is the field humming, vibrating, sending ripples across its own surface. When you see a star, you're witnessing vibrations that began long ago, still travelling across the field, unbroken. Imagine again the surface of the lake. If the water is disturbed in one place, the ripples spread outward, but they also tell a story about where they came from. The timing, the shape, the wavelength. All carry information about the disturbance. Light does this too. Every photon that reaches your eyes or a telescope is not merely a ripple, it is a ripple with memory. It tells you something about where it began, how much energy was involved, and what path it travelled through the cosmic fabric. In this way, the field beneath everything becomes the medium through which the universe communicates. When an atom releases a photon, the field vibrates. When a star shines, the field vibrates. When your phone sends a message or a plant gathers energy from the sun, the field vibrates. The vibrations may differ in frequency or strength, but the underlying sea remains the same. We can go even deeper with this image. Imagine a spiderweb stretched across a garden. If a small insect touches the web at one corner, a vibration travels along the strands to the other corners. The spider feels the pattern and knows what happened. The web is a single structure, and any disturbance anywhere can be sensed elsewhere. The electromagnetic field is like this web, but on a scale that dwarfs comprehension. A ripple begins in one part of the universe, and if nothing stops it, it can continue forever. Even more softly, imagine you're lying in a quiet field at night. You feel the grass beneath you, the earth supporting you. Now imagine that beneath the grass lies a deeper ground, invisible yet real, connecting the whole world. The electromagnetic field is that deeper ground. It is not energy itself, but the place where energy can flow. It is not the ripples, but the water that hosts the ripples. What makes this even more beautiful is that the field never rests. Even in what we call empty space, tiny vibrations flicker in and out, like the faint trembling of a string in a violin when another note is played nearby. These subtle tremors don't produce light we can see, but they form a soft background hum, a reminder that space is never truly empty, but full of potential. And in this sea of potential, photons move effortlessly. They are the travellers most deeply connected to the field, the ones that ride its waves with perfect ease. Unlike particles with mass, photons are not weighed down. They are made purely of the field's motion, and so they can glide through space at the universe's maximum speed without hesitation. Their existence is inseparable from the medium they move through. A photon is not something in the field, it is a pattern of the field itself. This perspective reveals something quietly profound. If everything is built on fields, and light is the most free and expressive vibration among them, then light is not a thing separate from space. It is an aspect of space, a way that space chooses to move. It is the universe expressing itself through motion. When you consider that every moment of sight, every star in the night sky, every message sent through fibre optics, every warm ray of sunlight touching your skin, all of it is the field vibrating. You begin to sense a deeper unity. The world is not made of separate, isolated pieces. It is woven from a single, continuous presence, one that hums with quiet life. And as we continue farther into this story, our next step is to look at humanity's search for an even deeper unity. The dream of finding one pattern, one principle, one underlying simplicity from which all forces and all forms of light arise. When you're ready, we can drift gently into session 14, where science and philosophy meet in the quest for a unified theory. If you close your eyes and imagine the universe not as a collection of separate parts, but as a single, woven tapestry, you may begin to sense a quiet longing that has lived within human curiosity for centuries. This longing is the desire to understand how everything fits together, how the forces of nature, the particles of matter, the ripples of light, and the curves of space all emerge from a deeper, simpler foundation. Throughout history, thinkers have wondered whether the universe is built from many independent pieces, or whether those pieces are merely different expressions of one underlying truth. This gentle search for unity has shaped some of the most profound scientific ideas ever conceived. Our story begins with a dream that once seemed impossible. In the 19th century, electricity and magnetism were considered separate phenomena. Electricity shocked and sparked. Magnetism pulled on iron and guided compass needles. They looked nothing alike. Yet whispers of connection appeared. An electric current could create a magnetic field. A moving magnet could generate electricity. But these hints were scattered, tiny glimmers without a cohesive explanation. Then came a quiet transformation. A physicist named James Clerk Maxwell noticed that these separate glimmers were not separate at all. By looking carefully at how electric and magnetic fields behave, he found that they are two sides of the same phenomenon. When electricity changes, it creates magnetism. When magnetism changes, it creates electricity. Each one loops into the other, forming a self-sustaining dance. And from this dance emerges light, a wave in which electric and magnetic fields rise and fall together, moving forward through space. Maxwell's equations, which scientists usually express using symbols and calculus, can be softened into something simpler. Light is the breath of the electric and magnetic world, a self-propagating harmony born from their partnership. With this realization, two seemingly different forces became one unified field, the electromagnetic field. It was the first great unification in physics, and it changed everything. This was only the beginning. Later, as scientists explored the world of atoms and particles, they discovered that other forces, the ones that govern nuclear reactions, particle decays, and the structure of matter, might also be unified. Some of these forces appear different only because we view them through a cosmic lens shaped by conditions in the early universe. If we could turn back time to moments just after the Big Bang, scientists believe these forces would merge together, indistinguishable from one another. In that early furnace, the interactions that today seem distinct might have been expressions of a single, elegant rule. Albert Einstein, who reshaped our understanding of space and time, could not help but wonder whether gravity, the curvature of space-time itself, might also be woven into this unified tapestry. In his later years, he devoted enormous effort to the dream of creating one grand theory that would combine gravity with electromagnetic forces. He believed deeply that nature should be simple at its core, that the universe should be built on one harmonious principle rather than a scattered set of unrelated laws. Einstein never succeeded in completing this dream, not because the dream was flawed, but because the tools needed to realize it had not yet been discovered. Still, his longing planted a seed, and that seed has continued to grow. As the 20th century progressed, scientists uncovered an intricate framework called the Standard Model of Particle Physics. It describes 3 of the 4 fundamental forces: electromagnetism, the strong force, and the weak force, using fields and particles that interact according to beautifully structured rules. In this framework, light is simply one type of vibration within a particular field. Other particles, such as electrons and quarks, are vibrations in different fields. Everything becomes patterns in a layered symphony, not isolated objects, but notes arising from a single orchestra of fields. Yet gravity remains apart, elusive, subtle, operating on a scale so large that it refuses to easily blend with the microscopic world of quantum fields. It is the soft curve in space-time, the gentle bending of the cosmic fabric, while the other forces live in a realm of discrete vibrations and interactions. Scientists continue searching for a way to bring these 2 worlds together, the elegant geometry of space-time and the shimmering quantum dance of particles. This search has led to ideas like string theory, which imagines that all particles are tiny, vibrating filaments, each with its own musical note. It has led to concepts like loop quantum gravity, which suggests space-time may itself be granular, made of tiny loops of structure. It has led to thoughts of hidden dimensions, symmetries we cannot see, and unobserved particles that might bridge gaps between theories. But even these advanced possibilities can be softened. Imagine the universe as a vast harp with countless strings. Each string hums with its own vibration, and from these vibrations come the particles and forces we observe. Some strings produce notes that we know well, the notes of light, of electrons, of gravitational pulls. Others may vibrate in ways we haven't yet heard, producing hidden notes, faint melodies that remain undetected. The quest of modern physics is to understand whether these strings are all part of one instrument, one elegant structure that produces all the music of reality. What makes this search so touching is that it mirrors a deeper human feeling, a desire for coherence. We long to know that the universe is not a chaotic jumble of unrelated parts, but a living, breathing whole. We want to believe that the beauty we see in nature, the arc of a rainbow, the curve of a galaxy, the warmth of sunlight, arises from something simple and unified. And perhaps it does. Perhaps the universe is indeed woven from one fabric, one set of principles, one cosmic breath that appears in many forms. Light may be the most graceful of these forms, the ripple that travels most freely, the vibration that reveals the field beneath everything, the messenger that stitches the universe together. As we move gently forward, we drift toward the horizon of human understanding, toward the discoveries still waiting in the dark. When you're ready, Session 15 will explore the possibilities that lie ahead, the hidden particles, the subtle clues, and the new forms of light that may one day illuminate the unseen chapters of the universe. If you imagine all the knowledge humanity has gathered about light, everything from ancient myths about the sun to the most delicate modern experiments, as a small island, then surrounding that island is a vast ocean of mysteries still undiscovered. Light has been our guide since the dawn of time, illuminating the world around us and revealing the depth of the cosmos above. And yet, even after centuries of study, we stand only at the shoreline. There are forms of light we have never seen, particles we have never detected, and hidden symmetries woven into the universe that we have not yet learned to read. The future of understanding light is not merely a continuation of what we already know. It is an unfolding, like watching a horizon expand as the fog lifts, revealing mountains you didn't know were there. In this quiet session, we drift into the realm of possibilities, where science meets wonder, and where new forms of light may one day reveal the undiscovered corners of reality. To begin softly, imagine a world of dark light, a strange phrase, but one that hints at a concept scientists are actively exploring. The universe, as we observe it, contains far less matter than it appears to need. Galaxies spin too quickly. Massive clusters hold themselves together with more strength than visible matter can supply. Something unseen exerts influence throughout the cosmos. We call it dark matter, not because it is sinister, but because it does not interact with ordinary light. It neither glows nor reflects nor absorbs. It hides perfectly. Some researchers wonder whether dark matter might communicate in a language of its own, using a kind of light we cannot detect, sometimes called dark photons. These would be vibrations similar to the photons we know, but rippling through a hidden field that does not interact with our familiar electromagnetic world. If such particles exist, they might carry messages within the vast invisible realms of the universe, whispering in forms of light that our eyes and instruments have not yet learned to hear. Detecting such a phenomenon would be like discovering a new colour that no creature on Earth has ever seen, a colour that reveals entirely new landscapes. We're building delicate detectors, cooling them to unimaginably low temperatures, isolating them from noise, waiting for the faintest sign. These experiments are patient conversations with the unseen, listening for a tremble in the dark. Beyond dark photons lies an even broader idea that the laws of physics may be guided by hidden patterns or symmetries that bind different particles and forces together. A symmetry in physics is like a repeating motif in a piece of music, a pattern that gives structure to what otherwise might seem chaotic. If we find new symmetries, we might uncover relationships between light and matter that have remained invisible for billions of years. Modern physics has already uncovered many such patterns, but the deeper we look, the more it seems that a grander structure might lie beneath. Imagine peeling away the layers of a beautiful painting and discovering that each brushstroke was guided by an unseen grid. The universe might work in a similar way, with hidden principles directing how light interacts with matter, how fields ripple, and how particles arise. New telescopes are being designed to help us explore these possibilities. Some of them stretch their mirrors into shapes never before used, like giant eyes turned toward the early universe. Others orbit Earth above the blur of the atmosphere, studying faint glimmers of light from galaxies formed just after the beginning of time. These instruments collect whispers, tiny traces of photons that have travelled billions of years, and from those whispers we hope to reconstruct lost chapters of cosmic history. One particularly exciting frontier is the study of gravitational waves, ripples in space-time itself. Although gravitational waves are not made of light, they interact with light in subtle ways, and together they may form a new kind of cosmic language. Imagine watching ripples on a lake and seeing how sunlight dances across them, revealing their shapes. In a similar way, Gravitational wave observatories reveal collisions between black holes or neutron stars, while telescopes read the light from those distant events. By combining these two sources of information, we may uncover secrets that neither alone could reveal. Quantum networks, systems that use entangled photons to send information, are another frontier. These networks are still in their infancy, but they could one day form a new internet built not on cables and wires, but on the strange, delicate connection between photons that remain linked across space. This quantum communication could be so secure that no eavesdropper could intercept it without disturbing the light itself. It could also allow information to travel in ways that defy our everyday intuition, not faster than light, but using correlations so subtle that they feel almost instantaneous. In a softer sense, think of quantum networks as a kind of emotional metaphor, a reminder that connection does not always require physical proximity, that bonds can survive distance, and that communication can occur through shared structure rather than direct transmission. The search for future discoverers also extends inward to the smallest particles. Some scientists wonder whether light itself may have companions we have not yet discovered, heavier cousins, fragmented variations, or modes of vibration that only appear at extremely high energies. Others ask whether light might behave differently in exotic places, like near the edges of black holes, or in the early universe's first moments, when conditions were too extreme for our current understanding to apply. These questions remind us that the story of light is far from finished. Every major leap in physics has come from looking at light in a new way. Newton studied the rainbow and developed laws of motion. Maxwell studied electromagnetic waves and discovered that light is electricity and magnetism dancing together. Einstein studied the speed of light and reshaped space and time. Quantum physicists studied the smallest interactions of light and matter and uncovered the probabilistic world beneath certainty. So it seems fitting that the future of physics will continue this pattern. Each time we examine light carefully, the universe reveals a piece of itself. Perhaps the most comforting thought is this: we are surrounded by possibilities we have not yet learned to sense. Just as ancient humans could not have imagined radio waves carrying voices, or lasers carving metal, or fibre optic cables holding the world together, we too are likely standing on the edge of discoveries that will one day feel obvious. New forms of light may fill our future technologies. New patterns of illumination may reshape our understanding of existence. And through it all, light will continue to guide us, as it has always done, revealing, hinting, whispering, illuminating pieces of the unknown. When you're ready, we can continue into Session 16, the final chapter of our journey. It is here that all these threads come together: light as physics, light as life, light as memory, and light as meaning. The quiet bond that connects us to the universe. If you were to drift far above the Earth, far beyond clouds, beyond satellites, beyond even the quiet orbit of the Moon, and look back at our world, you might feel something gently shift inside you. You would see a small glowing sphere suspended in darkness, blue oceans, white spirals of clouds, a faint shimmer along the horizon where sunlight brushes the atmosphere. From that vantage point, Earth looks fragile, almost delicate, yet it radiates warmth, motion, and life, and all of it, every breath, every heartbeat, every forest, every shimmering city, is an expression of light. As we arrive at the final stretch of our quiet journey, it becomes clear that light is not simply a physical phenomenon. It is a constant companion woven into every part of our existence. It shapes the cosmos at its widest scales, guiding galaxies into spirals and revealing the deep structure of space-time. It fuels the delicate machinery of life, filling leaves with energy and breathing oxygen into the air. It carries our thoughts across oceans through invisible fibers and touches our minds every morning, telling us that a new day has begun. Light traces our memories, carves our identities, and frames the way we see the world. In a very real sense, you're made of light. The food you eat is sunlight, transformed by photosynthesis. The warmth in your body is energy that once existed in the heart of the sun. The colours you perceive are stories written in the rhythms of photons. Even the atoms within you were forged in the light-filled hearts of ancient stars. Each breath you take is a gift from sunlight captured by forests and plankton. Each thought you think is powered by electrical signals, tiny currents in your neurons that rely on the same electromagnetic field that gives birth to light. This idea might feel vast, even overwhelming, but we can soften it into something more personal. Imagine tracing your own life backward through time. Every meal you've ever eaten, every beam of sunlight that has warmed your skin, every object you've ever seen, all of it ultimately connects to light. The apple on your table began as a flower that drank sunlight. The wood in your home grew from a tree that reached toward the sun. The page of a book you once held was formed from fibers fed by sunlight on distant afternoons. The people you love, the pets you care for, even your own bones, they're all built from energy that once travelled across 93 million miles of space before landing on Earth. The sun is not the only source of the light that shapes you. Starlight plays its role too. The atoms in your body, carbon, oxygen, nitrogen, calcium, iron, were forged in stellar furnaces long before Earth existed. When those ancient stars reached the end of their lives, they scattered their elements across space, mixing them into clouds that would one day collapse into new stars, new planets, and eventually into you. Your body carries the memory of these distant fires. In the quietest sense imaginable, you are starlit dust that learned to breathe. If we look outward again, to the vast universe that surrounds us, we see that light forms bridges across unimaginable distances. Galaxies separated by millions of light years still speak to us through their photons. When we gaze upward, we are not isolated observers looking into a remote void. We are part of an ancient conversation. The universe extends itself to us through every ray of light, through every faint glimmer that reaches our eyes. And in return, we extend ourselves to the universe by observing, understanding, and reflecting upon what we see. This interplay is not just scientific, it is emotional. There is a stillness that settles over us when we watch a sunrise or a campfire or a star-filled sky. Light has the power to guide our moods, shape our memories, and soothe our minds. It creates moments of clarity and calm. It reveals the beauty in ordinary objects. It turns shadows into stories. It paints landscapes with warmth or coolness, changing the way we feel without ever speaking a word. Light is also the thread that connects us to each other. Every message you send, every photo, every call, every whispered thought carried across the world travels on waves or pulses of light. We build friendships, share experiences, and maintain relationships through the movement of photons. Even in silence, even in solitude, we are never disconnected from the global web of light that binds humanity together. And beyond humanity, beyond Earth, light ties us to the cosmos. It links us to distant galaxies, to ancient stars, to the birth of the universe itself. The photons that reach you from the night sky began their journey across billions of years, long before your ancestors walked the Earth. Some of those photons came from stars that no longer exist. They are memories preserved in motion, carrying ancient chapters of cosmic history into your present moment. This realization can inspire a kind of gentle humility. Each of us is a small part of something immeasurably vast, a vastness threaded together by light, and yet, at the same time, each of us is a unique expression of that vastness. You're not separate from the universe looking in. You are the universe, looking at itself through your own eyes. Your consciousness, your thoughts, your emotions are made possible by the same physical principles that shape the stars. The boundary between you and the cosmos is thinner than it seems. Light passes through that boundary freely, carrying information in both directions. Perhaps the most comforting truth is this: light keeps nothing for itself. It shares whatever it knows, wherever it goes. It carries warmth without exhaustion, information without judgment, memory without forgetting. It never demands anything in return. It simply travels, illuminates, and reveals. It is pure giving. When we say that light connects everything, we mean it literally and metaphorically. It forms the skeleton of cosmic structure, fuels the chemistry of life, binds our digital world, shapes our perception, and inspires our imagination. It is the quiet thread weaving through all existence, tying together galaxies, planets, organisms, atoms, and thoughts. As you rest in this understanding, you may feel a soft sense of belonging, an awareness that you are part of something ancient and ongoing, something that glows in every star and every cell, wherever you're in the world right now, whatever light surrounds you. Moonlight, lamplight, the glow of a screen. You're connected to the same universal tapestry that has unfolded for billions of years. Light carried you here. Light sustains you. Light remembers. And through you, light continues its story. If you'd like to proceed to the closing summary or wind down message, just let me know.